Okay, hey, it's Griffin. I'm going to try to explain how to do the problems that we can do earlier, 64 and 66. My phone is like bouncing on my computer screen, so hopefully it doesn't fall off. Hopefully the audio is good too, whatever, I'll get into it. So essentially what we're trying to do is we want to get this definite integral, which is in the general formula. You know, we have our endpoints a and b, we have our function f of x, and we have d of x, which is later going to be our delta x, the change in x. And so this is kind of equivalent to what we are given in our problems, which is going to be the limit as n approaches infinity of summation of I equals 1 to n, and this is what it kind of breaks down to. So this is going to be f of x, and this is dx. dx is change in x, this is delta x, change in x. But this is the important thing, that a plus I times delta x is how we're going to figure out kind of the x value that we're starting at to put into the function f of x. So in this diagram, for example, we have like some line, and we have the points A and B. And so breaking down this part, which is going to be a very essential part of figuring out all these problems, we first want to know what A is, because we want this distance, and we're going to have to add it to say if we want to find x1, x2, or any x all the way up to xn or b. And so to find like how far is x2 from the origin, I'll do x1 because that's what I have written, but you would apply this to any step, is first you need a, you need this distance, and then you're going to multiply I times delta x, because if delta x is the change each time, say we want x1, which is, I equals 1, then we need 1 times delta x, which is this short distance, and then we're going to add a to it to get the total distance, which is going to give us the x value of x1. And then essentially you would plug that into f of x, and it would give you the point on the graph, and then you would multiply it by delta x to get the area of the rectangle. And that's what we're adding up to essentially get the integral, all the space underneath the graph. So yeah, kind of boiled down, this a plus I times delta x is going to get xi of whatever I is to plug into f of x. So that's going to be very important. We use that to find the x coordinate. So now I'm going to kind of do problem 66. That's the second of the two we're given. So we have ln equals, ln, the left Riemann sum, equals 2 over n, blah, 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 yada, yada. All this, I'm going to just kind of put it next to the equation that I'm going to line it up with that I had first, which is limit as n approaches infinity. And I'm going to change this to be f of x and delta x. And again, we have this equation right here, so that's what we're going to want to find. We're going to start by finding delta x, which is pretty easy because it's kind of given to us. It's the constant multiplier that it sets out in front, which is 2 over n, so delta x, 2 over n. Now we want to find this a plus I times delta x. So we're going to take everything that we have currently in our equation. We're going to drop it down. So we want to try to solve the variables within here. And so first I'm going to break down this 2i minus 1 over n. If we know that there's a delta x in there, and we have our I, we know delta x is 2 over n, and in this case, this I is going to be I minus 1, because we're at the left Riemann sum, which, that means we take I minus 1 is the ith number that we're getting. So you can kind of flip all these around. I just kind of made them all their separate things. 2 times I minus 1 times 1 over n, it's the same thing. And then I kind of flip them around, put I minus 1 here just to match it up with this. You put the 2 times 1 over n is 2 over n, which is our delta x. So you get 1 plus I minus 1 times 2 over n, which is our a plus I times delta x formula. Now, because we have this, we figured out that a equals 1. So that's going to be important in finding the correct interval for our integral. And so we know delta x is b minus a over n. We know that the delta x is also 2 over n because at the start of our equation we're kind of given that. So you just plug in 1 for a, you get b minus 1 over n has to equal 2, therefore b has to be 3. 3 minus 1 is 2. So now we've got these. So we've got the start of our integral, which is the endpoints 1 to 3. So now we have this. We want to find what is f of x. And the delta x that we have from earlier just changes into the d of x. D of x, delta x, they're kind of the same thing. But we want to figure out this f of x. And that was the part that always confused us. Confused me, at least. So we go back to this equation at the start that we're given, 1 plus 2i minus 1 over n, it's the a plus I. And in the end, this is the hard part to describe, but nothing is changing it. We're given this, this is the start of our thing, and this whole equation is just giving us this x coordinate right here. It's giving what the x to the ith coordinate. So, you can plug in anything for I, and it'll just give you the next one, and we're getting xi that we're going to plug in to f, this is xi. But there's nothing acting upon it because we're just, it's hard to describe, but this is just xi. This is just the x coordinate. And so because of that, f of x is just x. Whatever we get for this, whatever we get for the x coordinate is also the y coordinate. Like essentially what I'll show in the picture is it's just a straight line, the slope of x. So nothing's changing it, so f of x is just x. So that gives us the integral from 1 to 3 of x dx. And so that would be like a good final answer. To kind of show how this might change is if what we were given at the start was, we were given at the start with the Riemann sum and everything, if our number was like 1 over I plus 2i minus 1 over n, and that is squared, then, and this is just what I think, it would be like I over x squared. This x is what we found earlier. But then there's these outside forces, the 1 over and the squared, that act on that. So that is how it could change. Now, there's another thing that kind of shows how we could get another answer for this problem. When I break it back, when I was breaking it down to a plus I times delta x, I plus 2 this, and I kind of figured out that a equals 1. Well, what if I thought of it as a was 0? What if there was like 1 plus 0 plus 2i minus 1 over n? Then I would say a equals 0. You can solve this all the way out, do the same things. But if I call a is 0 and I have that 1 plus b outside of it, well, let's start. A is 0, and I know delta x is b minus a over n. B minus 0 over n, because I'm plugging in a as 0 now, because that's what I solved it a different way. And to solve that means b must equal 2, which is different, because now we have the integral from 0 to 2 instead of 1 to 3, like up there. But now we're solving for f of x dx. So what we have left over from our equation is this 1 plus this, which is x. This is just our xi, x sub I. So now this 1 plus is outside of this equation that we found. So now we add it back into that f of x, so it's 1 plus x. So we have the integral from 0 to 2 of 1 plus x dx. Now, I'll show you in this next picture that they are the same thing. 1 to 3 of x dx is the same as 0 to 2 of x plus 1. It kind of makes sense because if you think like you plug in 0, 0 plus 1 is 1. The endpoint, if you plug in 2, 2 plus 1 is 3. You can see how they're kind of the same. If you put it in a calculator, like an integral calculator, they're both going to equal 4. But I do have a picture of both of these graphs. This is the first one. I prefer this one. I don't know why either of them work, but integral from I over 3 of x dx. Well, our function is x, so it's just a straight line. You know, if you plug in 1 for x, you get 1. So, you know, 3, everything lines up. It's just a straight line. And if we're getting the integral from 1 to 3, you know, we're getting the area under that graph. So if you know, make a triangle, make a little rectangle, you got 1, 2, and then this is a 2 by 2 cut in half, so 4 divided by 2 is 2. Total area of 4. You get this graph that is the integral from 0 to 2 of, oh, I wrote x plus 1, but I know earlier I described it as 1 plus x. Same thing, kind of. I mean, it is the same thing. Anyways, you know, that slope is going to be the slope of x plus 1. It starts at 0, 1, and it's going up at that same angle. We're taking the integral from 0 to 2. Area of the graph under there. You count the squares, it's the same thing. You also get the area of 4. So that's, I think, how you do the problem. I think the biggest emphasis out of this is really you understanding that this a plus I times delta x is to get x sub I, which goes in here. And if there's any outside functions acting on it, that's what changes it. Hopefully this helped. I can already tell it's a long video, so sorry I didn't think it would be this long. But yeah, if you have any questions, just ask me.